Assalamualaikum and a very nice day I bid for our panels, Dr. Mat Salim Selamat and Puan Rahma binti Syahril. We would like to present our project titled The Numerical Solution of Bernoulli Equation using Daftardar Gejji and Jafari method. And our supervisor is Puan Rosha binti Muhammad.
My name is Nur Asikin binti Johari as the group leader, followed by my fellow members Nur Shahirah binti Ramlan and Yasmin Natasha binti Mohtar.
Numerical methods are very helpful in solving numerical problems in many fields such as natural science, social science, engineering, medicine and more. Besides, it is possible to solve linear and nonlinear equations using numerical methods. Next, it also provides results in a shorter time and solve equations that cannot be analytically solved. Next, the Bernoulli equation is one of the topics that we have studied before, so it's familiar and easy for us to do some research on this topic. As we know, Bernoulli is applied in our life such as the lift airplane wings and the air pumps. The formula of Bernoulli equation is y prime plus pxy equal to qxy power of n. Moreover, the Bernoulli equation has two types of equations which are linear and nonlinear. It is a linear equation when the power of n is equal to 0 and 1, and for any value of n which are other than 0 and 1, it is a nonlinear equation. The Daftardar Gejji and Jafari method is the method that we use in this proposal. It has been used to solve various types of problems successfully. Daftardar Gejji and Jafari method used to clarify nonlinear thin field flow problems can derive the result of the thin field flow of a non-Newton fluid, and has been used to figure out problems in many kinds of differential equations. Therefore, why don't we try this method to apply the nonlinear or Bernoulli equation?
Daftardar Gejji and Jafari method is one of the new numerical methods that is used to solve nonlinear equations. As for the Bernoulli equation, it exists in linear and nonlinear equation. The connection between the Daftardar Gejji and Jafari method and Bernoulli equation both are related to nonlinear equation. Thus, in this proposal, we would like to determine whether the Bernoulli equation can be solved using Daftardar Gejji and Jafari method for nonlinear equations. Aside from that, we are using the results from the Adomian decomposition method. The problem statement is to analyze which method is more effective between Adomian decomposition method and the Daftardar Gejji and Jafari method by obtaining the error analysis and to make comparison about which methods give the least error values. First objective that you want to achieve in this proposal is to solve the Bernoulli equation using Daftardar Gejji and Jafari method as to prove the uses of the Daftardar Gejji and Jafari method in numerical solution. Our second objective is to compare the numerical solution of Bernoulli equation using Daftardar Gejji and Jafari method and Adomian decomposition method by identifying which method is effective.
The findings of this research are to see whether Daftardar Gejji and Jafari method can be applied in solving nonlinear problems of the Bernoulli equation. By doing this proposal, it could give ideas to other researchers about the suitability of using this method in any fields, not only related to the Bernoulli equations, but to other equations too. It is possible to produce new inventions regarding the other uses of Daftardar Gejji and Jafari method in other applications, since this method is simple and new. According to Jaivan Petit and Sachin Balekar in 2015, DGJM is known as an impressive process for solving the nonlinear equation such as fractional differential equation, partial differential equation, and system of nonlinear functional equations. According to Yasser Daud and Ahmad Iqdir in 1980, the Adomian decomposition method, ADM, was the first presented, and the method is one of the efficient methods to solve nonlinear and linear problems. For the methodology, we started with understanding the basic idea of Daftardar Gejji and Jafari method by studying the method and figure out the series terms from the article that we searched. Next, we proceed by solving the two different types of nonlinear equation known as problem 1 and problem 2 by implementing the DGJM. The next process is by performing error analysis between DGJM and ADM. On top of that, the value of x that are applied in the study for both methods are between 0 to 0.01. For this proposal, we will use the absolute errors formula, which is the subtraction between the exact values and the DGJM values. The error analysis will be shown in the form of tables and graphs. Lastly, we will make a comparison of the absolute errors between the two methods based on the error analysis.
There are two problems discussed in this proposal. For problem 1, the equation of Bernoulli is nonlinear equation with the initial condition and exact solution. By using Daftardar Gejji and Jafari method, the series solution is obtained. Here are the results from problem 1. The table shows the comparison between Daftardar Gejji and Jafari method and the exact solution from x equal to 0 to x equal to 0.01. We choose a lower value of x to find a smaller value of error and help to compare their efficiency for both methods easily. From the table, the absolute error of Daftardar Gejji and Jafari method is increasing from 0.0004 40917 to 0.0009 95347. The line graph illustrates the comparison between Daftardar Gejji and Jafari method and the exact solution. As we can see from the line graph here, the blue line represents Daftardar Gejji and Jafari method and the red line represents the exact solution. Based on graph, it can be seen that the value of Daftardar Gejji and Jafari method increases when x increases. Next, we did a comparison for Edomian decomposition method with the exact solution. The table shows the value for Edomian decomposition method is increasing too. However, it gives a smaller value of error compared to the Daftardar Gejji and Jafari method just now. The table beside shows us the value of error for Edomian decomposition method is increasing. Next, this is the line graph for ADM for problem 1. From the figure, we can conclude that Daftardar Gejji and Jafari method is less efficient in gaining smaller value of error for equation of problem 1.
We move to our second problem of the proposal. For problem 2, the equation of Bernoulli is also a nonlinear equation with the initial condition and the exact solution. By using Daftardar Gejji and Jafari method, the series solution is obtained. Here is the table of comparison between Daftardar Gejji and Jafari method and the exact solution. From the problem 2, Daftardar Gejji and Jafari method occurred the error value of 0 and 0.00000001 in between of the value x equal to 0 to x equal to 0.01. The findings of the analysis here indicate the smaller error of the Daftardar Gejji and Jafari method has been achieved. Next, we move to the line graph. The graph indicates the comparison of Daftardar Gejji and Jafari method and the exact solution. There are two lines in the figure which represents the Daftardar Gejji and Jafari method and the exact solution. The lines are close together, expressing how small the value of error can be achieved. Next, the table displays the comparison between Edomian decomposition method and the exact solution for problem 2. From the table, we can observe that Edomian decomposition method achieved an increasing error value from 0 to 0.000006. We can see that the lines from the graph are slightly apart from each other. Thus, from both methods just now, we can summarize that Daftardar Gejji and Jafari method is more effective than Edomian decomposition method in solving the equation of problem 2.
In conclusion, the objective of solving the Bernoulli equation in Daftardar Gejji and Jafari method was successfully achieved to prove the use of the Daftardar Gejji and Jafari method in numerical solution. The goal is to solve the Bernoulli equation, which is a nonlinear equation that has also been successfully achieved using the Daftardar Gejji and Jafari method, named by problem 1 and 2. The second objective is to analyze numerical analysis of Bernoulli equation by using the Daftardar Gejji and Jafari method and the Edomian decomposition method to determine which method is effective. From our research on problem 1, the Edomian decomposition method shows more efficiency than Daftardar Gejji and Jafari method because the errors are smaller. But for problem 2, however, it turns out that the Daftardar Gejji and Jafari method is more effective than the Edomian decomposition method because the value of the error obtained is smaller. Hence, the second objective was successfully accomplished. In conclusion, the behavior of Daftardar Gejji and Jafari method and the Edomian decomposition method depends on the Bernoulli equation that we will use.